On March 22, 1989, the world was busy. The Cold War was thawing, the Berlin Wall was months away from falling, and people were going about their Tuesday morning coffee, driving to work, and hugging their children goodbye. But what no one knew, not the President of the United States, not the Soviet premier, and not a single astronomer on the face of the planet, was that a cosmic shotgun had just been fired at our heads. A mountain of rock, moving at over 40,000 miles per hour, sliced through Earth's orbit. It passed through the exact point in space where our planet had been just 6 hours earlier. 6 hours. That is the duration of a flight from New York to London. That is a good night's sleep. In cosmic terms, 6 hours is not a miss. It is a grace. It is a bullet parting your hair. If Earth had been just slightly slower in its rotation around the Sun, if that asteroid had arrived just a fraction of a day sooner, the year 1989 would not be remembered for the fall of the Berlin Wall. It would be remembered as the year a nuclear-scale catastrophe reset human civilization. This isn't sci-fi. This is the story of Asteroid 4581 Asclepius, the rock we didn't see until it was already gone. Today, we are going to break down the physics of a near miss, the terrifying reality of kinetic energy, and how this specific event woke humanity up from a long sleep. If you want to understand the universe and how we survive in it, make sure you hit that follow button right now. We are diving deep into the science of planetary defense. Let's go. To understand the fear, you have to understand the context. Today, we have the Pan-STARRS system, the Atlas Survey, and NASA's Center for Near-Earth Object Studies. We have a digital fence around our planet. But in 1989, the fence was full of holes. Actually, there was barely a fence at all. On March 31st, 1989, 9 days after the close approach, American astronomers Henry Holt and Norman Thomas were reviewing photographic plates at the Palomar Observatory in California. They noticed a streak, a fast-moving object that wasn't there before. They did the math. They calculated the trajectory backward, and their blood must have run cold. They realized this rock, which they later named 4581 Asclepius, after the Greek god of medicine and healing, ironically, had passed within roughly 684,000 kilometers of Earth. Now, I can hear you saying, 684,000 kilometers? That sounds far. And sure, in human terms, that's almost twice the distance to the moon. But in gravitational terms, in terms of orbital mechanics, that is microscopic. The terrifying statistic that made headlines wasn't the distance in kilometers. It was the distance in time. Because Earth is hurtling around the Sun at about 67,000 miles per hour. When astronomers say Asclepius missed us by 6 hours, they mean that Earth passed through a specific intersection in space. 6 hours later, Asclepius rushed through that exact same intersection. Imagine you run a red light. You don't see any other cars, so you keep driving. A week later, you check a traffic camera and realize that a semi-truck doing 80 miles an hour crossed that intersection 2 seconds after your bumper cleared the line. You didn't feel the wind. You didn't hear the horn. But you were 2 seconds away from game over. That was Earth in 1989. So what exactly was this thing? Was it a planet killer like the one that wiped out the dinosaurs? Let's look at the data. 4581 Asclepius is an Apollo asteroid. These are a specific group of near-Earth asteroids that have orbital axes greater than Earth's, meaning they cross our path regularly. Asclepius is estimated to be roughly 300 meters wide. That's about 1,000 feet. To visualize this, imagine a rock the size of 3 football fields, or roughly the height of the Eiffel Tower. It's not a solid ball of iron, but likely a rubble pile, a loose collection of rocks and dust held together by weak gravity. Now, 300 meters sounds small compared to the 10-kilometer monster that killed the dinosaurs. Asclepius was not an extinction-level event rock. If it hit us, humanity would not have been wiped out. We wouldn't have gone the way of the T-Rex. However, do not mistake survivable for safe. A rock of this size falls into the category of a city killer or a small regional killer. The danger comes from one simple equation that rules the universe. Kinetic energy equals 1/2 mass times velocity squared. The mass of Asclepius is huge, millions of tons. But the velocity is the real killer. The velocity is squared in the equation, meaning if you double the speed, you quadruple the energy. It hits the atmosphere at tens of thousands of miles per hour. When it stops, all that energy has to go somewhere. It turns into heat. It turns into a shockwave. It turns into an explosion. Let's play out the what if. Let's assume Earth was 6 hours late to the intersection. What happens when Asclepius hits? Upon entry, the atmosphere acts like a brick wall. The air in front of the asteroid cannot move out of the way fast enough. It compresses, heating up to temperatures hotter than the surface of the sun. Scientists estimate that an impact from a 300-meter object releases energy equivalent to roughly 600 to 1,000 megatons of TNT. The largest nuclear weapon ever detonated by humans was the Tsar Bomba. That was 50 megatons. Asclepius would have been 10 to 20 times more powerful than the largest nuke in history. If it hits land, it creates a crater 5 kilometers wide and hundreds of meters deep. Everything within a 50-kilometer radius is instantly incinerated by thermal radiation. A shockwave flattens buildings for hundreds of kilometers. If it hits a city like London, New York, or Tokyo, the city is gone. Not damaged, vaporized. The surrounding suburbs are leveled. The economic fallout crashes the global market instantly. But Earth is 70% water. What if it hit the Pacific Ocean? An ocean impact might actually be worse in some models. The explosion creates a cavity in the water, sending up a tsunami. While modern simulations suggest deep ocean impacts dissipate energy better than we used to think, a strike near a coast would send megaton energy waves slamming into the shorelines, devastating coastal cities across an entire hemisphere. This was the bullet that missed us by 6 hours in 1989. A multi-megaton bomb with no politics, no ideology, and no mercy. Just physics. The Asclepius event was a turning point. Before 1989, looking for asteroids was considered a niche hobby for astronomers. It wasn't a priority. Governments were worried about ICBMs from other countries, not rocks from other planets. But when the data from Asclepius came out, the United States Congress took notice. They asked a simple question: how many more of these are out there? The astronomers' answer was terrifying: we don't know. This led to the Space Guard Survey Report in 1992. It led to a mandate from Congress for NASA to find 90% of all near-Earth objects larger than 1 kilometer. Asclepius proved that the sky isn't empty. It proved that space is an active shooting gallery. But I want to circle back to something educative here. Why did it miss? And will it hit us next time? Orbits are not perfect circles. They are ellipses. And they change. The gravity of Jupiter, Earth, and Mars tugs on these asteroids, slightly altering their path every time they go around the Sun. When an asteroid passes Earth, Earth's gravity pulls on it. If an asteroid passes through a very specific, tiny region of space, called a gravitational keyhole, Earth's gravity will tweak its orbit just enough so that, on the next pass, it hits us dead on. This is what we fear most. It's not just about missing us today. It's about missing the keyhole that sets up a collision for tomorrow. Luckily, subsequent tracking of Asclepius showed us that it is not currently on a collision course for the foreseeable future. We have mapped its orbit with high precision now. We are safe from this specific rock. But the lesson remains: you cannot dodge a punch you don't see coming. Fast forward to today. The legacy of Asclepius is visible in our modern planetary defense strategy. In September 2022, humanity did something incredible. We punched an asteroid in the face. The NASA DART mission, Double Asteroid Redirection Test, slammed a spacecraft into the asteroid Dimorphos. Why? To see if we could change its speed. And it worked. We altered its orbit. This proved that if we find an Asclepius-sized rock early enough, years in advance, we don't need to blow it up like in the movies. We just need to nudge it. If we change its speed by just a fraction of an inch per second, Over the course of 10 years, that difference adds up to thousands of miles. That difference turns a direct hit into a miss. Today, we are tracking over 34,000 near-Earth asteroids. We find new ones almost every day. The invisible bullet of 1989 would likely be spotted today by systems like Atlas. But likely isn't definitely. There are still blind spots. Asteroids coming from the direction of the sun are notoriously hard to see because the sun's glare blinds our telescopes. The Chelyabinsk meteor in 2013 came from the direction of the sun. It exploded over Russia, injuring 1,500 people. We didn't see it until it was burning in the sky. Asclepius was a warning. Chelyabinsk was a reminder. There is something humbling about asteroid 4581 Asclepius. It reminds us of our fragility. We live on a blue marble drifting through a chaotic debris field left over from the formation of the solar system. For all our wars, our borders, our economies, and our differences, nature has a way of leveling the playing field. A rock doesn't care who is president. A rock doesn't care about your stock portfolio. The story of Asclepius is the story of a cosmic coin toss that we won. We got heads. We got to keep playing. But it also taught us that we can't rely on luck. We are the first species in the history of this planet with the technology to prevent our own extinction. The dinosaurs didn't have a space program. We do. The 6-hour margin of 1989 is a statistic that should haunt you, but it should also give you hope. Because in the 30 years since, we have turned our eyes to the sky. We have mapped the heavens to protect the Earth. We are watching. We are calculating. And we are preparing. Asclepius missed. And because it missed, we had the time to learn how to make sure the next one misses too. Space is beautiful, but it is not empty. If you want to stay educated on how humanity is securing its future among the stars, and if you love deep dives into the science that governs our reality, please follow this channel. We have so much more to cover, from the physics of black holes to the engineering of future colonies. Don't miss the next episode. Thanks for watching, and keep looking up.